Problem number 6 from synthetic division number 2. And so I'm going to start by thinking of the possible rational roots. In the numerator, I'm going to list the factors of 24, or what evenly divides into 24. In the denominator, I'm going to list the factors of the leading coefficient. So we have lots of options. I'm going to press pause, and to save time in this video, I'm going to test the different integers that are integers, not the rational roots that involve the fractions. So I'm going to test 1, -1, 2, -2, 3, -3, 4, -4, and so on until I find one that works. All right, so I tested, this was very time consuming considering I don't have a calculator with me at home. I tested 1 and -1, 2, -2, 3, -3, and 4. None of those worked. I tested 4. I did this all on a separate piece of paper to save time on this video. So I'm going to show how -4 works. Hold tight with me as I go through this. So I'm multiplying to get -48. Now -48 and +32 are different signs, so I'm going to subtract to get 16. The larger sign is negative. Then I'm going to take -16 times -4 to get a +64. The difference here is 7. The larger number is negative. Multiplying -4 and -7 to get a +28. The difference here is 6, with the larger number being positive. Multiplying to get -24, and we can see that -4 works. So of these, I know that x equals -4 works. Remember, I tried 1, -1, 2, -2, 3, -3, and 4, and none of these worked. So what do I do with this? I have 12, -16, -7, 6 equals 0. To the left of the equal sign is no x's, or x to the 0, 1x, 2x, and 3x. So I always suggest the first thing you do is you ask yourself, can I go ahead and factor this using the factor by grouping method? So off to the side, I'm asking myself, what am I able to factor out? And I could factor out a 4x squared. I'd be left with 3x minus 4. But when I write 3x minus 4 over here, I notice that there's no integer value I can take times 3x and end up with a -7x. So factoring by grouping isn't going to work. So what's my next option? Well, I'm going to go back to synthetic division. I'm going to identify the constant and write down the factors 1, 2, 3, and 6. And then I'm going to come back to the leading coefficient, write down 1, 2, the factors again, 1, 2, 3, 4, 6, and 12. Now let me list these out for us. I'll put it on. So I've decided to demonstrate how I'm able to list these possible rational roots. So I'm going to take this 1 and each one of the numerator values and place it over 1. So 1 over 1, both positive and negative, 2 over 1, 3 over 1, and 6 over 1. Then I'm going to slide over in the denominator to 2, so I have 1/2. So positive 1/2 and negative 1/2. Now I take 2 over 2, but I know that reduces to 1. I have 3 over 2 and -3 over 2 as a possible rational root. And I know 6 over 2 reduces to 3. Sliding over to 3, I have 1/3 positive and negative. I have 2/3 positive and negative. 3 over 3 is the same as 1, and 6 over 3 reduces to 2. Sliding over to 4, I have positive and negative 1/4. 2 over 4 reduces to 1/2. 3 over 4 has not been listed. 6 over 4 reduces to 3/2. Sliding over to 6, I have positive and negative 1/6. 2 over 6 reduces to 1/3. 3 over 6 reduces to 1/2. 6 over 6 reduces to 1. Sliding over to 12, I have 1 over 12 and -1 over 12. 2 over 12 reduces to 1/6. 3 over 12 reduces to 1/4. 6 over 12 reduces to 1/2. So none of these here have been repeated. But now I have to remember that I've already tested 1, -1, 2, -2, 3, -3, and -4 with our original function. None of those worked. So I'm going to go back and cross out what I know doesn't work. The 1s, the 2s, the the 3's, and there's no positive 4 here. So I'm going to first start by checking 6 and negative 6, because why wouldn't I want to first work with the integer before I try anything else? So I'm going to go ahead and I'm going to test, hoping that one of these two produces an output of 0. And that would allow us to identify another one of the 4 roots. We already have one root identified as x equals negative 4. Okay, dropping down the 12. 6 times 12, I believe, is 72. 6 times 12, I believe, is 12 is 60. That would be correct. Okay, so 6 times 12 is 72. Now 72 minus 16, they're different signs. I'm going to subtract them, keeping the sign of the larger number. 56 times 6 is 336. But then I have to subtract 7 to end up with 329. 329 times 6. Okay, and I can stop. Like, I don't need to continue to add this. And the reason for it is that all I'm looking for is which number, when I test it, produces an output value of 0. Because if it produces an output value of 0, it is in fact a solution. 6 doesn't work. I can come up top and I can cross out 6. Let's try negative 6. So we're going to multiply to get a negative 72, combine to get a negative 90. Now if I take 6 times 90, I get, 540. Let's see, that should be a positive. This is going to be 533. And I already know this isn't going to work because 6 times 500 and some, and then I add 6 to it, that doesn't give me 0. So kind of disappointed here. None of my integers, when I looked at, as a reminder, I tested the first one off to the side, trying to save ourselves time. None of these works. The first one from the original list of possible rational roots that worked is negative 4. I took this remainder then to create a secondary equation, and that's what I'm using to test right now. So I'm just going to go through the list. I'm going to try 1/2 and then negative 1/2. Let me grab another piece. Let's try 1/2. So I'm going to drop down to 12. And I multiply half of 12, or 12 divided by 2 is 6. I combine to get a negative 10. Half of negative 10 is negative 5. Combine to get negative 12, and half of negative 12 is negative 6. Ooh, a lucky. So 1/2 also works. So I'm going to go up to the very top, and I'm going to identify another one of the 4 solutions that I'm trying to use synthetic division and factoring to identify, using algebra, not a calculator, is positive 1/2. What can I do with this? So I have 0, negative 12, negative 10, and 12. No x's, 1x, and 2x. Right away, I can see that they all are divisible by 2. So I can factor to 2 to get 6x squared minus 5x minus 6 equals 0. Okay, and now is it possible that I can factor this? And if not, I'll use the quadratic formula to solve. What multiplies equal negative 36 and combines to give us a negative 5. I know there'll be different signs because two numbers multiplying to give us a negative mean they're two different signs. I also know the larger number of the two will be negative. Okay, 1 and 36, no. 2 and 18, no. 3 and 12, no. 4 and 9, 4 and 9 will work. So 9 and 4, multiply and combine. When the leading coefficient is not a 1, it's a little bit more work. We write down the A, we write down the C, and now I take these two chosen values and I place them in the middle. And now I'm going to use factoring by grouping as a way to solve this. So I'm going to factor out 3x. I'm left with 2x minus 3. 2x minus 3. And then I ask myself, what times 2x gives us a positive 4x? 2. There's your 4x, and there's your negative 6. So the front and the back both contain 2x minus 3. In front of the first parentheses is 3x, and the second is positive 2. Set each factor here equal to 0 to solve to find the two remaining solutions. Add 3 to the opposite side, divide by 2, and the third solution is 3/2. Okay, next I'm going to subtract 2 to the opposite side, divide by 3, and the final solution is a negative 2/3.